All right, we're doing linear functions. So who knows what linear functions are? So we already know that functions are what? What are functions? Who remembers what functions are? We did this yesterday. They're what? Two variables. Who remembers what functions are? A function is what? Is a pair that what? Has an input and exactly what? One output, right? So it has inputs and outputs and exactly has what? Each pair of inputs is going to have exactly what? One output to function, correct? If it does not have basically one input. Inputs are your what? Let's go back and let me reword it. If I have more than one input, which are those? Are those my X or my Y's? If I have more than one, what happens? It's not a what? It's not a function, correct. So in linear, think of the word linear. What does linear mean? What is the first four letters in the word linear? Line, okay? So always think about it as the linear function is going to be something with what? A line, okay? And there are times that it could be a function and not be linear. So what will be the opposite of a linear if it's not a line? It's going to be called non-linear, okay? So you're going to have linear and non-linear functions. Now, how do we identify a linear function? It's going to have what? Two variables, an x and a what? A y. And it's going to be an equation that's going to be written in the format of y equals mx plus b, where m and b are always constant. So what do you guys think your m is, your y and your x? Do you see the y and the x? Those are your what? Those are your variables, correct? Those are your two variables. So you are going to do what? You're going to work on your equation to solve for who? For y. So you're going to have your input and then you're going to have your output. Which is your dependent variable here? Which is your dependent variable here? Y is your dependent variable, right? And x is your what? Independent variable, okay? So let's look at the next slide. We're going to work. Remember, nonlinear function does not have a constant rate of change. What does that mean? Linear means that there's a constant change of rate. So sometimes it could be what? Increase, and sometimes it could be what? Decreasing. So it all depends. Let's just work some examples. Let's go on to the next slide. Let's first identify a linear function using graphs. Does the graph represent a linear or non-linear function? A, is that linear or non-linear? Is that linear or non-linear? It's what? Is there a line? A, we're looking at A. Okay, raise your hands if it's non. Raise your hand if it's linear. Raise your hand if you have no idea. Some of you didn't raise your hand, so all right, it's going to be, it's not a line, okay? That's not a line. That looks like an what? What letter does that look like? A U, right? Not exactly a U, but there is a curve there, right? So that's going to be a what? Non-linear. Again, remember, linear is going to be a line. Okay, it's going to be a line. We remember our lines, right? A line is what? It's a straight. It's going straight, correct? Is A going straight? So that's why it's going to be called what? A non-linear. It's not a line. What about B? Is the graph a line? So that is going to be, the function is going to be what? Are these both functions? They're both functions, okay? Why? How do I know they're both functions? What theory? Yes. Yes. We are always going to test the what? The vertical line test, right? So none of the points are touching, right? More than once. Let's go on to the next slide. This is when you identify it in a graph, okay? Using the graph. Now we're going to have identifying the function using the tables, okay? So does the table represent a linear or non-linear function? Let's look at A. What does this one, X, goes by? What's it climbing by? By what? Is it all climbing by 3? Correct? What about Y's? What's the pattern in Y? By what? No, it's subtracting by 6. Correct, Ethan. It's decreasing by what? By 6. What does that mean? While X increases by 3, Y is what? Decreases by -6, right? Is there a constant rate of change there? Is that constantly happening? Is my 3 happening constantly? As each input goes through. Is the Y, my outputs, constantly changing by -6? So that's going to be a what? A linear. It is constantly changing, okay? So remember, it needs a linear function needs to be constant. The rate of change must be constant. Everything is changing constantly. Let's look at B. What is X changing by? By what? By 3? It's going by 2, so that means my X is increasing by +2. What about my Y? What's happening in my Y? What's happening in that first one? What does increase by? +7. What about in the second one? What about in my... So that is increasing by different amounts, right? It's increasing by a different amount. Is my rate of change constant there? For X is constant, right? But for Y, is Y constant? So this is going to be a what? Non-linear. That's going to be a non-linear. A non-linear. Okay, we're ready to go. Remember, constant change of rate describes the quantity that changes by equal amounts, okay, over each intervals, okay. Let's go on to the next slide. Now we have using equations. So we've done graphs, tables, and now we're going to what? Identify the linear function using equation. What did we say the linear equation is? It could be written by what? Y equals what? Mx plus B. So let's look at the first one. I'm going to underline it in red here. Y is what? 3.8. Would that be a linear function? Can we rewrite, what I want you guys to think is, can you rewrite that equation to look like y equal mx plus b? That's just telling me y equals what? 3.8. Do I have an x there? Do I have an x? So it cannot, can we rewrite it though? Yes, how? Even though I do not have an x, can x still be a 0? So I could rewrite that one as what? Y equals 0x plus what? 3.8. Just because I don't have an x there, I'm still able to see it what? As a linear function, okay? So that's going to be linear. Let's look at the second one. The second one is what? It's a radical there, right? Of what? There's an x there. Can I rewrite that as a linear function? No. So, not linear, okay? That cannot be written as a what? Cannot be linear. What about the third one? Let me erase here so we could see. The third one is what? Y equals what? 3 to the power x. Can that be linear? Can I rewrite that as a linear? No, because my x is what? It's in the power. It's a power, right? It's to the power of 3. So that's going to be, cannot be written as a linear function. Okay, what about the next one? Y equals 2 over x. Cannot that be rewritten as a linear function? No. Then we have which one? Y equals can we turn that one into? What can we do there to turn that into y equals mx? We have what? Y equals 6 times what? I'm going to do what first? Distribute property, right? So what do we have here? Y equals 6x minus 6. Is that linear? That is linear. And finally, we have a what? X squared minus y equals what? X squared minus y equals 0. Can we rewrite that in a linear function form? So that one's going to be not a linear. Do we see the difference? Okay, so even if I have y equals, let's say, 5, that's going to be linear because you could rewrite as what? Y equals 0x plus 5. And that is a linear formation, okay? We're going to continue practicing, but I just want you guys to understand. Okay, let's go to the next one. So the concept is what? When you have them in table, when you have it in a mapping diagram and a graph. Are there, an output is 3 more than the input, okay? So look at the input and output table. That are all functions, okay? Those are all functions. If you look at the mapping, let's look at the input-output table. For the x is climbing by what? What's the constant rate of change in x on the table? What's the constant rate here? +1, right? And what about on this side? +1. So they're all what? They're constant, correct? So that is a function. Look at the mapping diagram. Do I have what? Is that the definition? Does it fit the definition of what a function is? For every input, we have exactly what? One output. What about the graph? Is that linear? The line is going straight, right? It's not curved or anything. So this concept summary is just for you guys to go back and look into it if you have questions. Graphing linear linear functions, sorry. A solution of a linear equation in 2 variables is an ordered pair. So remember what ordered pairs are, right? Xn. If they don't have a parenthesis, what does that mean? Is it an ordered pair if there's no parentheses? No. So we're just going to, if there's no parentheses, we're just looking at x, the letter x and the letter y, and it's separated by what? By a comma. So the graph of a linear equation, 2 variables, is set points are x and y, okay? In a coordinate plane that represents all solutions of the equations. Sometimes the points are distinct and other times the points are connected. What does distinct mean? Separated, right? And sometimes they're what? Connected. So we're going to look at what it means, discrete and continuous. What is discrete? Who can read for me what discrete is? Who can read what discrete means? Go, Harmony. Interval, right? So the example is integers from 1 to 5. And all those points are what? They're just points, right? Number 1 is graph. Number 2 is graph. 3 is graph. 4 and 5. Are they all connected? But now in continuous the word continuous means something that keeps going, right? Continuous. So always remember, continuous means something that keeps going. Is a set of input values that consist of all numbers in an interval. That means it's inclusive. Think of it all included. So all numbers from 1 to 5. Now, do you remember when we had the and or in compound inequality? We had and or. Or was what? Two separated, right? And was what? Intersecting, right? So think of continuous as something that is all together and you're discrete as separated. So let's look at how do we graph a discrete data. The linear function is what? Y equals 15.95x represents a cost, which is Y in dollars, of X tickets for a museum. Each customer can buy a maximum of what? 4 tickets. So we have 4 is important. What else is important? The equation, right? Y equals 15.95x. So what is the first thing they're asking us in A? Find the domain of the function. What do you guys think the domain is here? Huh? 4 is one of them. Can we split tickets? When you go and buy tickets to go to the entrance to something, you're like, okay, I just need half a ticket. Do you say that? You have to buy the whole ticket or don't buy it at all, right? So here it's telling me Y equals 15.95x. X is a representation of how many tickets you can buy. Y is 15.95 is the cost, correct? X is how many tickets you can buy, and obviously that's independent, but who's dependent? My Y, right? So it all depends how much tickets I purchase is going to be my total. But what's the maximum that you can buy? 4. So we're going to have what? Do we have to buy tickets? Do you have to buy tickets? Yes? Do you have to? No. Are we ever? Do we have to? No, right? So we're going to start at what? 0. Okay, we're going to start at 0. And we're going to have 1, 2, 3, and? Because 4 is the maximum. What does maximum mean? Can they buy 5 tickets? Can they buy? They're like the Taylor Swift concert. You're going to maximum buy what? 4 tickets. There is a maximum. You cannot buy no more than 4 tickets. Correct? So always think that there is always sometimes a maximum or a minimum. Sometimes they tell you can only buy 2, minimum of 2 or greater. So let's look at this. We're going to create a table with this, right? What are the 0 through 4 going to be? Is that our input or our output? Is that our input or output? Input. Good. That's going to be our input, which is our what? Our X. Remember, we're going to do coordinate. We're going to use a coordinate plane eventually, and this is our ordered pair. What was the equation? 15 what? 1595 times X. And what is it going to be our output? We need to work it out. And then finally, we're going to have our ordered pair. Our output is what? Y, correct? So what is 1595 times 0? It's going to be what? 0. So our first order pair is going to be what? 0, 0. Correct? Because we have our X and our Y. What about 1595 when I purchase 1 ticket? What's going to be my output? $15 what? What's 1595 times 1? What's 1595 times 1? 1595. So my order pair is going to be what? 1 what? And 1595, correct? What about when I purchase 2 tickets? It's going to be 1595 times 2. What is 1595 times 2? What is it? 1595 times 2. No? Somebody? $31 what? $31.90. So my order pair is going to be what? 2 and $31.90. What about when I buy 3 tickets? It's going to be $15.95 times 3. What is $15.95 times 3? 47 what? 85. So my order pair is going to be 3 and 47.85. Correct? And finally, what if I was to buy 4 tickets? What is going to be my price on that? $63.80. So my order pair is going to be 4 and $63.80. Am I able now to find my domains? Do we already know what my domains are, right? What are my domains here? So I could answer. I am now able to answer these questions. Find the domain of the function. What is the domain here? What are my domains? We forgot what our domains are? Huh? I can't hear you. I'm sorry, Santiago. Yeah, what are my domains here? Who doesn't remember our domains? What are our domains? Our domains are X. What's her range? Y's. So my domains here are what? 0, 1, 2, 3, and 4. Am I able to see if this is going to be discrete or continuous? Is this going to be discrete or continuous? If I was to plot it, it's going to be what? Discrete. Why is it going to be discrete? What do you guys think it's going to be discrete? It consists of individual points. It does not, is it individually? Are all these tickets you're buying individually? We're going to do one graph with continuous so you guys can see. It's individual points. All these are individual points. Okay? This is not a continuous. Remember when I said before was what? All numbers 0 to 5 is continuous. But if we have what? If you have only certain numbers, are these not certain numbers? All numbers from 1 to 5 will be considered continuous, or all numbers 0 to 4 will be continuous. But this is discrete. Why? It only consists of certain numbers. Will you need to buy all 4 tickets? Can you buy 3 tickets? Can you buy 2 tickets? So it's only certain points. Let's look at B. Graph the function using its domain. In your in Notability, when you do your homework or any classwork that I give you, you know you have graph paper there, right? When you open a new, what is it? Okay, so if I was to graph it, you're going to have what? X is here and Y, right? What am I starting here at 0, right? What's going to be the bottom one? Is the bottom one going to be number of tickets or the cost of dollars? My X is what? Remember, the numbers, right? Because the X, our inputs was what? 0, 1, 2, 3, and 4. And the cost was what? We cannot start by $15.95. We cannot start by $31.90. We could do what? Increments of, that is basically climbing by, we could do increments of 10, right? So it could start climbing by 10. We could have 0, 10, 20, 30, 40, 50, 60, and 70. We'll stop at 70. Who remember what was my first one? My first one was 0, 0, correct? My first one was 0, 0. What was it when I purchased 1 ticket? What was the total of one ticket? It was 115 what? $15.95, right? So it's going to be somewhere around here, correct? What about when I had 2 tickets? It was a total of what? Nobody wrote it down? Nobody wrote it down? It was 31 what? 31.90. What about when it was 3 tickets? 47.85. And 4 tickets was what? 63.80. So my graph, is it linear? Am I connecting these? Obviously, if it's a line, is what? You will see it keeps climbing up, right? So it all depends. It is a linear, but it's going to be what we call a discrete, okay? It's a discrete graph. Let's go on to the next example. Now we're going to do continuous. So notice before we were buying what? You were buying tickets. But now it says a cereal bar contains 130 calories. The number C of calories consumed is a function. Is a function of the number of B of bars eaten. Does this situation represent a linear function? Is this a linear function? When B, what is B? What is B? Let's look at B. Let's look at A. A tells us what? That B increases for what? When does B increases? How does B increases? By what? A cereal bar. A. What does A mean? What does A mean? 1, right? A means 1. A cereal bar. How many cereal bars we have? 1. Contains how many calories? 130. The number of calories consumed is a function of the number of B of bars eaten. So that means if I eat 1 bar, how many calories is being consumed? So that means that B increases by what? By 1. And who is B? As B increases by 1, C increases by what? $130. Who's C? C's are calories and B is the bars, okay? So if I increase to 2, what will be my, if B goes, B is B2, what will C be? To what? 260. And it's so on, right? It increases as now, just by this one, can we tell if this is continuous or what? Does it present, is it a, first of all, is it a linear function? It's a linear, so we know it's linear. We know it's linear. Is it continuous or discrete? It's going to be continuous. Why do you, I know that this is where you guys like, but why is it continuous? What's the difference between the discrete? Why do you think it's continuous? Bless you. Added. Can you eat half of a bar? Can we eat 1/4 of the bar? If I eat half of the bar, how many calories am I eating if I eat half of the bar? What is it? 65, right? So I'm eating 65 calories. So in the bar, you're able to eat half of it. You're able to eat 3/4. But in a ticket, one before, can you break that ticket into pieces and say, I'm going to buy just half of the ticket. So I'm going to go into the concert, only watch half of the concert. So I want half of the ticket. Can you do that? No, you have to buy the whole ticket or none at all, right? But in a bar, you're hungry. You start eating and you start eating that cereal bar. But all of a sudden you get to bar number 3 and you're like, okay, I'm just want a little bit more. That's what we call it continuous, right? So think of this first, always think of the situation. Is it individual or can it be continuous? Okay. The domain is going to be what? Your domain is, you could use domain what? Your domain is going to be B, okay, domain is greater than or equal to 0. What does that mean? That's your domain. What does that mean when B is greater than? You're going to eat more than 1 bar, right? but it has to be more than what? 0. So it's to start. So you could be 1 is going to be greater than or equal to 0. If you decide not to eat no bars, then it's 0 is greater than or equal to 0. Is that correct? But what if you want to eat 1 or 2? Is the B always going to be bigger? It's always going to be greater. Got it? Let's go on to now just identifying. Let's practice. 1. Is that the graph. This is a graph. Does the graph represent a linear or non-linear? What is it? Linear. What about number 2? This we know it's, let me do it another color so we could see it. We know that this is linear. What about number 2? Is it non-linear or linear? I know where you guys can get confused, but you're like, it's non-linear. But is it still a function? It's still a function. It's just not linear because it's not a line. What about number 3? Table 3. It's what? What is x increasing by? And y increases by 2. And it's constant, right? It's a constant rate of change. What about 4? Non what? Why? Because x is constant, right? It's increasing by 1. But what's happening with y? It's decreasing by, first of all, by different numbers, right? First it decreased by half, and then it decreased by another, what, half and half. But it's not what? It's not continuous, okay? So it's going to be a non-linear, okay? The rate of change is not constant. Let's look at number 6. Does the equation represent linear or non-linear? Remember, what are we looking for? Y equals mx plus b. This is key to remember. Is 5 linear? 5 is linear, correct. What about 6? Huh? It's linear. Why is it linear? Can I rewrite that like this? Y equals 3 over 5x plus 0. 3x over 5. Okay, put here. What does that mean? I could break it down. I could break down my fraction as 3/5 and my x out. What about 7? Is 7 linear or non-linear? Why? Because we have this, an exponent of x squared. Got it? We have an exponent of x squared. Now, number 8. This is the graphs that we've been working on. We're not going to graph it completely, but we're just going to find domains of the function, okay? The linear function m equals 50 minus d represent the amount so m is dollars of money you have after buying DVDs, which is going to be d. Find the domain of the function. Is the domain discrete or continuously? So just by looking at it, do you think with the word problem, do you think this is going to be discrete or continuously? It's going to be what? Discrete. Why you say it's discrete? You cannot break the DVD into half, right? Can you grab that DVD and be like, I'm just going to watch half of the movie, so I'm going to break it in half? So it's going to be, we already know it's going to be what? Yes, hon. Because he says that he cannot break the DVD into half, that he cannot go into store and buy what? Half of a DVD. Okay, so you have to think of the situation.
If it's constant, it means you
No, not you mean continuous. Yes. Constant means that's with. So that means that discrete. This is discrete. And what do you think my domains are going to be here? Domains are going to be right. Can I start at 0? Can I start at 0? Do I have to buy the DVD? It's going to be what? 0. And what else can I go up to? The linear function m equals 50 minus 90 represent the amount of dollars of money you can have after buying DVD. Find the domain. Domains are my x, right? Did it tell me how the maximum? Did it tell me the minimum of how many DVDs I can buy? But what's the minimum? 0, right? What else can I have? So I'm just going to go 1, 2, 3, 4, and 5. Can I still go on? Yes. But I'm going to stop at what? At 5. Okay? I'm going to stop at 5. Why? Because the DVD has to be a whole number. Having at least 5 inputs will give me a graph. Okay? Will give me a graph. It will be enough for me to what? Graph. If I only do 2, at least always try to do 3 to 4. So that you could do what? So you could have a graph. Okay, let's go to the last one. Number 13. I mean, not number 13, slide 13. We have here what? In number 9. Is the domain discrete or discrete? Let's look what it says. Number 9, just looking at it. Let me, should I expand it here so you could see it better? Okay. Is the domain discrete or continuous? The domain. Which is my domain? Remember, my domain is what? My inputs, right? My output is going to be my what? Range. That's why it's important to understand the vocabulary. Sometimes you're just going to see range, input, output, a dependent, independence. That's why you have to memorize what X and what Y is. So looking at it, is the domain discrete or continuous? Is this discrete or this is continuous? Number 9. It says height of building, number of stories. Would that be discrete or continuous? The height of the building depends on the number of stories, right? Can that be discrete or continuous? Discrete. Why? Can you go into a building and say we're going to have half of the building here? Like this is the floor. And we're like, I just want half of the height of the building halfway. No, right? So you're going to have what? That's discrete. Number 10. A 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number G of gallons remaining is a function of the number of M of minutes. Does this situation represent a linear? Is this linear? Why is it linear? There's going to be a rate of change, doesn't it? How many gallons did the bathtub of? 20 gallons, right? And it's decreasing by what? It's draining. Draining means what? Decreasing, right? It's going down. It's going down by what? 2.5 gallons per minute. That means that when it's at 5 minutes, it's already what? I mean, at 1 minute, it's 2.5 gallons. In 2 minutes, it's going to be what? 5 gallons has been drained. In 3 minutes, 7.5 gallons have been drained, correct? So, does this represent a linear function? Is there a constant rate of change there? Yes. Why? Why is there a constant rate of change? M increases while who decreases? While M increases 1 minute, 2 minutes, 3 minutes, 4 minutes, what is happening in my gallons? They're what? They're decreasing by what? 2.5. So yes, it is a linear. Now let's find the domain. What are the domain of MB? What is the domain in B? Define the domain of the functions. What are my domain of my function? Do we have a domain? First, is it discrete or continuous? Continuous. We know it's continuous. Why is it continuous? Because it's going to get to a point of what? This is 20 gallons, correct? It might get to a point that what is happening to the water? Is it draining? Continuously, right? So what will be the domain of the function here? Who can tell me what will be the domains here? Remember, the tub could what? Drain for part of a minute. For part of a minute, right? It is doing what? Draining per minute. So what will be my domain? You start at what? At 0 is less than a minute. Minutes are my what? M is my domains, right? Less than or equal to what? 8. Why 8? What do you think it's going to be 8? Is 8 times 2.5 20? $2.5. What's 2.5 plus 2.5?
$5.
5, right? So that means plus 2 more. So 5 plus 5 gives me what? 10. Plus 5 more gives me what? And plus 5 more gives me? So that's what's 8 minutes. So it's going to take how many? How long it's going to take? Not how many. How long is it going to take to drain completely? 8 minutes. So it's going to start at 0 minutes and has to be less than or equal to the minutes and minutes less than or equal to 8. And do we understand what happened there? Yes, no. We have to start critically thinking sometimes.